Welcome to section 9.6 and 7, where we're going to talk about graphing our quadratic function, our x squared, if you will. And what we're going to do is we're going to find all kinds of patterns in our quadratic graphs. We're going to look for things like the vertex, LOS, which stands for line of symmetry, a counting pattern for your y coordinates. This is kind of what we call the quadratic slope, if you will. And your parabolas will have a max or min value. So to start this all off, we're going to look at our basic quadratic function, y equals x squared. And I'm going to pick all the non-negatives. So I'm going to start at 0 down here. So if you printed out the notes, we're looking at that tall, skinny graph. We're just going to look at the top half for right now. So I'm going to choose a 0. And put 0 in for x, and 0 squared is 0. So that gives me the point 0, 0, and I'm going to come down and I'm going to plot that point. Then we're going to try it when x is 1. 1 squared is 1, so that's the point 1, 1. 1 to the right, up 1, plot that point. Then we're going to try a 2. 2 squared is 4. That's my y coordinate, so that gives me the point 2, 4. So there's 2, 4. Then the 3. 3 squared is 9. 3, 9 is my next point. So let's see, that's 2, that's 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Plot that point. And next we have 4 squared is 16. So that's the point 416. So let's see, this was at 9. So that would be, this is 4, then 10, 11, 12, 13, 14, 15, 16. And then when x is 5, we square that, we get 25. Okay, so we said that was 16. All right, that's 5 for the x, and that would be 17, 18, 19, 20, 21, 22, 23, 24, 25, all the way up to the top. Now, if we look at these points, and now take a look at 1 through 5, and if we made those x's negative, and you square those negative numbers, they would still become the same positive values that we have over here. So all these points are going to flip over the y-axis, which we call the line of symmetry. So your line of symmetry goes through this bottom point, which soon we'll call the vertex. And this point here was 1 squared to the right. Then there's another point 1 squared to the left, because we're literally flipping it over that line. 3 squares away, 3 to the left. 4, 4 to the left. 5, 5 to the left. And there's my graph. Then what you might want to do is, because you'll probably have to, if you have to graph some big graphs in the future when it's on paper, just use a straight edge, the side of your ID card, a calculator. You can pretty much make those all straight lines until you get to these bottom 3 here. This is where you need a curve. There cannot be a sharp corner here. It's a smooth curve. Then you can straight edge those, and that's good. You'll notice that I put my arrows on the last dots. Don't extend your arrows at any given time, because this function has to pass the vertical line test. So for example, at this point here, when I test my students' paper pencil, their curve somehow magically just goes straight up. Well, that doesn't pass the vertical line test. Or their curve comes back inside, or it goes out too fast. Just hit that last point, put the arrow right there, and call it good. All right, now the next thing we're looking for is a pattern. Well, right away you can see the pattern in your x's. My x's, they all counted by 1. Now if you look at your y coordinates, 0 to 1, okay, that increased by 1 too. 1 to 4, that increased by 3. 4 to 9, that's a 5. And you might see what's going on. It's always an odd number. My next number would be 11, and 25 plus 11 is 36, and that's 6 squared. 36 plus 13 is 49. That would be 7 squared. So your pattern here is from the origin, your vertex here. from the vertex where you have this curve. The vertex is known as the turning point. At that turning point, your vertex, you're going to start this pattern. Now, slope of a line is usually rise over run. Now we kind of do the x first when we go x squared. We're going to go 1 to the right, up 1, plot that point. Then 1 to the right, up 3 squares, because that's this difference right here. So we're going to get into the habit here of not having to make tables, but use this pattern to find your next points, kind of like what you did with slope. So this point here, you go 1 to the right, up 5. 1 to the right, up 7. 1 to the right, up 9. And you fill in your graph with as many points as you can. On the right-hand side, put in your line of symmetry, or some authors will call it axis of symmetry, and you flip your points over that line, and now you can make the left-hand side. This is symmetrical to the y-axis, or your line of symmetry right now. So this 1, 3, 5, 7, 9, 11, 13 pattern, this sequence of odd numbers, is always in every x squared function. Okay, no matter what you add, subtract, multiply, divide to your x squared, it has to exist there. It's there some way, shape, or form. Okay? Now, my next example. Y equals 3x squared. So if I use the same points, we're going to go 0. 0 squared was still 0 times 3. You're still at the origin. 1 squared is 1 times 3 will be 3. Plot that point, 1, 3. 2 squared, 4. 4 times 3 is now 12. Holy cow, we're going up really fast. Let's see, that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's our point. 3 squared, holy moly, I think we're going to fall off the graph because we're up here at 25 before. Okay, this is as far as we can go. But I'm still going to put up the numbers 4 and 5 just so you can see the pattern. So my 3 squared, 9 times 3, 27. 4 squared, 16 times 3 is 48. 5 squared is 25 times 3 is 75. I want you to see the pattern. So we'll finish our graph since this is as far as we can go. Put in your line of symmetry. You don't have to go all the way to the top. I just copied and pasted. You can just stop right here. Flip over all your points. Draw in your curve. Remember, we need a smooth curve at the bottom. And these can be straight lines. You can use a straight edge. Arrows right here. Again, like I said, don't let your arrow go past. If it curves inside or goes and crosses this column of squares right here too soon, then it's going to be wrong. So just stop right there. It's all good. Now, looking at our patterns, again, ones haven't changed for the x's. But now my y's increased by 3, increased by 9, increased by 15, increased by 21, increased by 27, and you lied to me. Where's my 1, 3, 5, 7, 9 pattern? I did not lie. It's here. The factors of 3 is still here. Look at the factors of 3. That's 3 times 1. Factors of 9, 3 times 3. Factors of 15, 3 times 5. 21, 3 times 7. 27, 3 times 9. There's your 1, 3, 5, 7, 9. It's just that it's all been multiplied by 3. And where did that 3 come from? Right here. That's the a in front of the x squared. When we did all our quadratic formulas, there was that ax squared plus bx plus c. This number always gets multiplied to your 1, 3, 5, 7, 9 pattern to determine how fast you are increasing with your points. So if I had to graph this the first time, without even making a table, I would say, okay, there's my origin, 0, 0. That's my vertex starting point, plot it. Then I look at this 3 and go, okay, 3 times 1 is 3. So 1 to the right, always 1 to the right, up 3. Plot that point. Then my next odd number is 3 multiplied by 3. That's 9. 1 to the right, up 9. Flip it over the axis or line of symmetry, and I have my graph. So we're going to adjust our pattern and not say 1, 3, 5, 7, 9 anymore. We're going to say 1 to the right, up 1A, 1 to the right, up 3A, 1 to the right, up 5A. So we want to say 1A, 3A, 5A, 7A. Now, this works for any numbers. If you look at our next example, we have a fraction here. All right, no more tables. We're going to use our pattern here. So to use your pattern, you state your vertex. It's still 0, 0 because nothing is being added or subtracted. Next, after you plot the origin or your vertex, we are going to go 1, 3, 5, 7, 9 and multiply a half to every one of those numbers. 1 times a half, we get 1 half, 3 halves, 5 halves, 7 halves, 9 halves. Now, how do we graph these? You simply count half a square. Now, I will never give you a test that I would make up where you'd have to do anything more than a half. However, Pearson, different story. All right, so here we go. If I'm going to graph this, I'm going to go 1 to the right, and you might want to put a little tick mark right here, and then count up half a square. There's my point. 1 to the right, put a little tick mark here, and then count up 1, 2, 3 halves. 1 to the right, put a little tick mark if you want. From there, count up 5 halves. 1, 2, 3, 4, 5. And again, if you want to put little tick marks here in all these spots, it's perfectly fine. 1 to the right, tick mark. Now count up 7 tick marks. 1, 2, 3, 4, 5, 6, 7. And when I said tick marks, I'm talking about half of a square. Whoops, 1 to the right. Now we're going to go up 9 halves. So starting here, you might want to put a little tick mark, dash mark, whatever you want. 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves. There's my point. Oh, I think we can get 11 halves in here too. 1 to the right, little mark. Up 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves, 10 halves, 11 halves. I've got no more graph to work with, so axis of symmetry, flip your points over. 2 to the right, 2 to the left, 3 right, 3 left, 4 right, 4 left, 5 right, 5 left, 6 right, 6 left, and draw your graph. Put your arrows there at the end. All right, now for the bottom half of that graph. For the bottom half, I have a -2, so now we're graphing below the negative side. So again, vertex at 0, 0, and we are going to start at that point, 0, 0, right here. Now my A is a -2, so 1, 3, 5, 7, 9, multiplying by -2 gives me -2, -6, -10, -14, -18. Now what this means is that because our product here is now a negative, we're not going to count up, we're going to count down. So when we have a positive A, we'll be counting up. When we have a negative A, we'll be counting down. So starting at this vertex here, 1 to the right, we're going to go down 2, right there. Draw your point. 1 to the right, down 6. 1, 2, 3, 4, 5, 6. There it is. Plot a point in there. 1 to the right, down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Plot your point. And I don't think we're going to get 14 in, so we're going to stop there. Axis of symmetry. Flip them over. 1 to the right, it's going to be 1 to the left. 2 to the right, 2 to the left. 3 to the right, 3 to the left. Draw in your curve, and we'll call it done. Okay? All right, now, I do want to take you back and show you how to graph these in more, to show you how you'd have to work that. So this video is going to end right here. I'm going to make another video for how to graph in more.